So, the quantum eraser experiment. It is very weird. It is a variation of the double slit experiment, which I did another video on. You should go back and watch it if you haven't yet. But the gist is, if you fire photons toward a double slit, then you will see an interference pattern. That's because the photon is in a superposition and it interferes with itself. But if you put detectors on the slits to figure out which slit the photon is going down, then the interference pattern disappears. The waveform has collapsed and it's only going through one of the slits, so it's not interfering with itself. So you can fuck with this experiment in really interesting ways that give you really interesting outcomes. If you, for example, split the photon into entangled pairs when it goes through the slits. You can have one set of photons go toward a screen, which will show a pattern, just like the double slit experiment before, and another set of entangled photons go to detectors. Now, if those detectors are off, the entangled photons still interfere with each other. So you turn off the detectors in one area, and then that affects the entangled photons in another area. If you turn the detectors on, then the entangled photons, again, don't interfere with each other. So, since we know something about the photon's entangled pair, that affects what we're doing to the original photons. Now here's the really wonky thing. This experiment has been used as a proof, air quotes for a reason, that the future already exists. Because let's say that you make the route to the detector super long. Like, longer than it takes the entangled pair to get to the screen to print out the result. In this case, the photons hit the screen and show a pattern that represents the state that the detectors will be in the future when their entangled pairs get them. It's as if information is being sent back in time. And there is another step of weirdness you can add to this. If you send photons through half-silvered mirrors, which basically says half the photons go through and half get reflected, and some get reflected to detectors, and then those remaining photons you basically scramble. You set up a mirror path so that they could go to two other detectors and you have no idea which one they're going to. You have effectively erased your knowledge of what slit the photons were going through. And again, you get an interference pattern even though the original detectors were turned on. And again, you could put these way far away, long enough that it would take light years to get to them, and it still would erase the knowledge you got from the detectors that were sitting right in front of you. Again, the future affects the past. These are real experiments that have really been done, and we have gotten real data from them. This has been observed. It's not just people dicking around ideas. Now, the reason why I air quotes earlier is because while this data is real, we have not yet come to a consensus on its interpretation. It might mean that everything's deterministic. It might mean something completely different. We just don't know yet.